Hello students, our today's topic will be to finding out the positions and the values of principal planes and stresses. At the last class, we have discussed about various conditions where a body is subjected to either direct load or with shear load, or with the both cases, that means direct stresses and shear stresses. And we have find out various normal stress and shear stresses for given oblique plane. So at the extreme last, we have discussed about the general condition where a body is subjected to direct stresses in all sides and shear stresses in all sides, and we have got two equations for a particular given oblique section which is having theta angle. We have got these two equations for normal stress on that particular given plane and the shear stress, right? Now, how to find out the principal plane and stresses? Now look at the definition of the principal plane. Principal plane is one plane which will be having only normal stresses, no shear stresses, right? So in this body there will be planes where the value of shear stress will be equals to 0, right? So by the definition we can say for principal plane we can set tau is equals to 0. So if tau is equals to 0, we can say sigma x minus sigma y by 2 sine 2 theta is equals to tau xy cos 2 theta, right? Now if you move this part in left hand side and this part in right hand side, you will be getting sine 2 theta divided by cos 2 theta, that is tan 2 theta. And if you move this part in right hand side, so you will be getting 2 tau xy divided by sigma x minus sigma y. Now from this equation, if the given stresses are known, sigma x, sigma y, tau xy, those are known, so you can find out the value of theta. Now theta is what? Theta is a plane, theta is a position of a plane which is having shear stress equals to 0. That means this is a position of the principal plane, right? Now if you consider this equation, you will be seeing that this is a equation, you can say this gives one triangle, a triangle, right? A triangle which is having this angle 2 theta and the height is equals to 2 tau xy and the base equals to sigma x minus sigma y, right? You can see this, right? Now there is another condition where this equation is also valid. What is the condition? The condition is if the triangle, this angle is 2 theta and this is minus 2 tau xy and this base is minus sigma x sigma y. In this condition also this equation is valid, right? So we can say there are two principal planes, that means two cases where this is valid, that means there are two principal planes in this body. Now if you see, you will be seeing that these two conditions are 180 degree apart, right? As because we can say that if this is 2 tau xy and this is sigma x minus sigma y, this is 2 theta, another condition will be over there where this will be minus 2 tau xy, this will be minus of sigma x sigma y, and this angle will be 2 theta, right? So this case and this case are 180 degree apart, right? So for 2 theta this is 180 degree apart, for theta this will be 90 degree apart. That means there are two cases, two planes which are having zero shear stresses. That planes are in 90 degree apart, means they are making a 90 degree, right? So two principal planes are there in two-dimensional body which are having 90 degree angle with each other. Now that means for two principal planes we will be getting two principal stresses, one will be higher and one will be lower. Now if you consider the diagonal value, what will be the diagonal value for this particular triangle? The diagonal value will be equals to root over sigma x minus sigma y square plus 4 tau x y square, right, for this triangle. And you can see for this triangle also this will be the diagonal value, as because if you square this and this, the negative sign will not be there. So diagonal value will be same for this condition and for this condition. Now if you consider the first condition, for first condition you can find out the value of sine 2 theta, that will be equals to height, that is 2 tau xy divided by the diagonal value, that is sigma x minus sigma y square plus 4 tau xy square, right? And you can find out the value of cos 2 theta also, that will be equals to a base divided by the diagonal value. Right? Now if we are getting those two values, now if you put the value of sine 2 theta and cos 2 theta in our equation number 1, cos 2 theta and sine 2 theta, it will give one value of sigma n, the sigma n value at the first case. So sigma n we are naming this, and if you put the value and simplify this, you will be getting the this. You will be getting this equation. So this is one principal stress. This we can say, as because we are taking the positive signs, this value will be higher. So this we can say this is the major principal stress, right? Similarly, for the second case, you will be getting a value of sine 2 theta, and this will be only the negative sign will be there, other part will be same, and cos 2 theta, where again the negative sign will be there, other part will be same. Like this, right? Now if you put this value again in equation number 1, you will be getting normal stress number 2, and this will be equals to this, right? So this is another principal stress, and this value will be the lower value, so we can say this as minor principal stress. Now we can see there are two cases where the shear stress will be equals to 0, and we will be getting the maximum value of normal stress and the minimum value of normal stress. So understand this one, that is, in a principal plane we'll be getting the normal stress value maximum one and the minimum one. That means in this particular body there will not be any kind of plane in which the normal stress is greater than this and lower than this. This is the maximum and minimum value of the normal stress in any planes in this body, right? Okay. Now suppose there is one example, one body is subjected to normal stresses 110 Newton per millimeter square in x direction, 47 Newton per millimeter square in y direction, 63 Newton per millimeter square shear stresses in all directions, right? Now they are saying that find out the major and minor principal stresses, and what will be the position of the principal planes, right? So to find out this one, this will be simple, right? As because you just have to put the values in these equations. What are the equation? For the first case, for major principal stress, suppose we are denoting with sigma n1. This value we have already got over there. This value is nothing but sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 square plus tau x y square root over, right? So if we put the values in this equation, that is sigma y x y by 2 plus root over sigma x minus sigma y by 2 square whole square plus tau x y square. So if we put the values, simply sigma x equals to this, sigma y equals to this, and tau x y equals to 63, you will be getting all the values. That is, this will be coming 148.936 Newton per millimeter square. Just you have to put the values. For the second case also similarly, if you put the value, this negative, there will be only negative sign, the other portion will remain same. So this value will be coming 8.064 Newton per millimeter square. Simply just put the values and we'll be getting that. Now what will be the position? The position, for the position we have already seen that we can use this equation, that is tan 2 theta is equals to 2 tau xy divided by sigma x minus sigma y, right? We can use this one. Just put the values, just put the value, you will be getting this value is equals to 2, right? Now if you find out the value of 2 theta, this will be tan inverse 2. This will give you two values, 63 degree 26 minute or 243 degree 26 minute. So for these two cases we will be getting the value of theta twice. Theta will be equals to 31 degree 43 minute or 121 degree 43 minute, right? So that is why we are saying that there are two possibilities for tan 2 theta. We will be getting two values 180 degree apart for 2 theta, so 90 degree apart for theta, right? So those are the position of principal planes. Thank you.